Today we have some examples of the derivative by way of the chain rule, which is expressed in one way here. What this says in English is that d dx of f of u. So let me try and take this one step at a time here. You have the derivative of f of u. Notice I didn't say f of x, because what we're looking for with the chain rule is a situation like this, where it would be a regular function if only this didn't say 3x plus 2. Instead, it's a composite function. It's a more complicated function within an otherwise simple function. So that requires one of the first steps with these sorts of things to be able to rewrite the given function as something like 3e to the u. And that's expected to be something we can take the derivative of. Now, in order to take the derivative of f of u, we must first find f prime of u. And I've always thought of this as the derivative of the main function. And what I mean by that is after we've established what u is and we rewrite it, we kind of have this main overarching governing function in this example here. 3e to the 3x plus u is thought of instead as the main governing function 3e to the u. Let's find the derivative of that by regular means, and you'll see what I mean by that. Actually, let's do it now. The derivative of this, y prime, would start looking like, well, the derivative of 3e to the u, which is a constant of 3 factored out. Now to do the derivative of e to the u, treating u as if it is a regular variable, the derivative of e to the u is e to the u. The derivative of e to the x is e to the x, that sort of thing. Now, you must take that and you must multiply it by du of du dx, and I've always referred to this as the derivative of the inner function. I mean the derivative of u. When we said that this function was being written as 3e to the u, we also said that u itself was being substituted instead of 3x plus 2. So in order to find the derivative of this thing, it should be pretty straightforward by our power rules. We'll have a 1 power here, bringing down and subtracting 1 there. We'll have 3 times 1, which is x to the 0 power, plus the derivative of 2, which is the derivative of 2x to the 0 power. By the same rule, we're going to have 0. So du dx, the derivative of u with respect to x, is simply going to be 3. And that is what's going here. So if we have the derivative of the overarching function in terms of u times the derivative of u itself. The last thing you need to do here is you need to put u back. You have to re-express this thing as a function of x as it was originally given. Putting u back is as simple as rewriting u again as 3x plus 2. And we have this new factor of 3 as a result of the derivative of that inner function, giving us at the end of the day 9e to the 3x plus 2 for the derivative of that function. So here we have an alternate example. F of x is equal to the natural logarithm of 3x squared plus 2x plus 1. So in order to tackle this, first I'm going to rewrite this as the ln of u. A very nice re-expression, and it's expected that we can take the derivative of something that resembles this using our formulas. Along with that, it goes without saying that we have stated that u is equal to 3x squared plus 2x plus 1. So the first step here is to find f prime of u. Take the derivative of ln of u, treating u as if it was just any other constant, like an x or something. We need to know that the derivative of ln of u is 1 over u. Now we must multiply by du dx, the derivative of u with respect to x. Du dx by our power rules is going to be 3 times 2x to the first power plus 2x to the 0 power plus 0, 6x plus 2, and that is what's going to go here. In place of du dx, we're going to put our 6x plus 2. Last thing is to put back u the way we found it. Instead of writing u, we'll resubstitute 3x squared plus 2x plus 1 and multiply it by our new factor of 6x plus 2. And that should be sufficient for the derivative of ln of 3x squared plus 2x plus 1. I'll see you in a few weeks with some more examples on this.